solving percent problems. Let's take a look at our first problem. A sports store received of 400 baseball gloves. 30% were left-handed. How many left-handed gloves were in the shipment? All right, some information we have. We have a whole amount of something, right? The sports store received a shipment of 400 baseball gloves. That's the total amount of baseball gloves. So this is a whole. We're going to call this whole. And you'll see why in a minute. And in fact, if we were to draw this, we could use a kind of tape diagram or a bar model and say, hey, this is 0 and this is 400. So this total amount of baseball gloves that they have is 400. We're given some more information. We're told that 30% were left-handed. So the thing we want to be thinking about is 30% a whole or is it a part? Because this is the whole amount of gloves. We're being asked down here how many left-handed gloves. So we're being asked for part of this whole. So is this 30%, is that a whole or is that part of something? Well, obviously, when we're talking about percent, whole would be 100. And this is not 100, this is 30. So this is part of the whole. So we could draw it kind of like this. We could guesstimate, right? We could say this is probably 50% right about there. So we could say 30% might be, I don't know, right there. Okay? 30%. Notice that we have 400 and 30%. Actually, if I wanted to make this a little bit easier to understand, we could do a double number line type of thing, have the percent on the top and the amount on the bottom. So what would be here? What percent would go there? Well, if this is the whole thing, if this is the total amount, then it would be 100 right there. So I hope that you can see that what we're trying to figure out is this guy, right? We know that when there's 0%, then there's no gloves. When there's 400 gloves, that's 100% of the gloves. We are told that 30% are left-handed, so we need to know that number of quantity of gloves. So how much is equivalent to 30%? We can do this problem a number of different ways, but because of what we have done previously with ratios and proportions, we're going to use proportional reasoning. So first thing to do is to identify ratios that we are given. And we can see ratios right here and even here if we wanted to. We're not going to need that one. So our ratio could look something like this. 100 is the percent, is the whole. And by the way, I'm going to put the wholes always on the bottom just to make sure our organization is consistent. It doesn't really matter which way we organize it, but I want to always keep our wholes on the bottom and our parts on the top, okay? So the whole of the percent is 100. Do we know the part of the percent? Yeah, we do. Part is 30, okay? 100% of the gloves is equivalent to something over here. 30% is equivalent to something else. So we need to write that as well. Let me change my color. Let's go with this. Okay, so what do we know as the whole to go for the quantity? Well, here's that whole right there, right? 400 is that 100%, right? Those two are equivalent, especially if I have percent sign. Right? 100% is equal to 400 gloves. 30% is equivalent to some number of left-handed gloves. Okay, I hope now that this is becoming very familiar to you. Again, I was saying that the 400 gloves is that whole, it's all the gloves. And so that means it's 100% of the gloves. So these two are equivalent to each other. And then 30% of the gloves are left-handed, and so we need to know the number of those. But this is now proportion. This is a ratio and a ratio that are equivalent, and so we can figure out how to go from one to the other. And so how do we go from 100 to 400? We can multiply by 4. And you guys know that both have to have the same operations. So if I were to do something like this, Now it's equivalent. We didn't break math because we're multiplying 30 over 100 by 1, which in this case we're going to use 4 over 4. So 30 times 4, what is that? I hope this makes sense what we did, right? We went from 100%, which is equivalent to 400 gloves. 30% then is equivalent to 120 gloves. So how many left-handed gloves were in the shipment? 120 out of 400, right? 400 is the whole, 100%, 400. 30% is the part we wanted to know, which we found to be 120, because to go from 100 to 400 is 4 of them, and 4 groups of 30 is 120. So let's try another one. This one is essentially the same kind of problem, except it's just saying simply what is 28% of 25. So we can have 28%, and we need to ask ourselves, is this the whole or part? And this percents will be the easiest thing for you to determine, because you know what a whole percent is. A whole percent is 100% always. So this is going to be part. And so we're going to place this on top of the fraction. Again, doesn't matter if you choose to put the parts on the bottom and the wholes on the top, it's fine. But for my sake, just to keep things consistent, we'll put this on the top of a ratio. Okay, like that. So the bottom of our ratio has to be the whole. So what is the whole when we're dealing with percents? It'll be 100. Okay, and actually, oops, sorry. So we have 28 out of 100 is that percent. Okay, this fraction is equivalent to this percent, 28 per 100, 28 per 100. This is the part, this is the whole. And I guess I can do this, like that. And this is the whole, okay? That means that we can now write another ratio that's equivalent to this with whatever the whole is and with whatever the part is. So do we know the whole or the part? What is 28% of 25? So do we want to know part of 25, or is 25 the part of some larger amount? What is 28%? What is part of 25? So this is the whole, because we want to know part of this whole. So if 25 is the whole, it's going to go down here with lined up with the other whole. 100% is the whole amount. The whole amount that it's equivalent to in this case is 25. And so what is the part? So we know the whole and we know one of the parts. So what's equivalent with this part? Again, we just have to look at how these proportions equate to each other. How do we go from 100 to 25 or 25 to 100? Because we know both of these, we don't know these. So we can't ask ourselves how to go from 28 to this, because we don't know what this is. Neither can we ask how do we go from this to this, because we don't know this. But because we know these two, we can say, how does 25 turn into 100, or vice versa? In this case, it's easier to say, well, 25 goes to 100. Let me draw this. 25 relates to 100 in that there are 4 25s that make 100. Now we could say this, and then we can work it the same way up here, right? We could say times 4, but the problem is we don't know what to multiply 4 by. So this does help us in a sense, but we're going to have to ask it in a different way. Okay, so instead of saying times 4 to go this direction, we're going to have to flip it around and go this way, which is the opposite, right? So how do we go from 100 to 25? Well, because times 4 was going this way, then we know that to go the opposite way means we're going to divide by 4. Okay, the opposite of multiplication in a sense, okay? So 100 divided by 4 is 25, and that means the same can work up here. So 28 divided by 4 is going to give us this. And we know that, well, what is 28 divided by 4? 28 divided by 4 is 7. And now we found what is 28%, what is part of this whole. 28% part of a whole of 100 is equivalent to 7, which is part of a whole 25. Let's try another. What is 35% of 60? All right. 35% is going to be part of what whole? 100%, right? Because we're dealing with percent, then we know that we can write it like this, 35 out of 100. Well, this is equivalent to something with this. So is 60 a whole or a part? Well, 35% of 60. So 60 is going to be the whole because we're trying to find 35% of it. We're trying to find part of it. So we can now ask ourselves, how do these two relate? We don't know how these relate, but 60 to 100. Wait a minute. I can't think of anything to multiply 60 by to get 100 off the top of my head, and I can't think of how to divide out to go this way. So we're going to have to do a little bit of tricky work. And what I would suggest is turning the 100% into some other multiple of 10. Specifically, if you can get it down to 10, that would be great. And if we can get this down to 10, then we can do a little bit of work to make ourselves get up to 60. See if you can follow along. I'm going to rewrite this guy down here, but I'm going to divide both by 10, okay? So I'm going to divide this by 10 and divide this by 10. And I can write that divided by 10, divided by 10. And we're going to get, well, what's 35 divided by 10? Well, anytime we divide by 10, all the digits move one place to the left. So that would be, instead of 35, it would be 3.5. And the 100 divided by 10 would give us 10. So these two are equivalent. So it's okay that I use this. But this is helpful because now I know, in fact, if I draw the rest of our proportion, I know how to go from 10 to 6. So 10 to 6 is 10 times 6. That means that I just need to multiply this guy by 6 as well, and I'll find out what the part of 60 is. That is 35%. So 3.5 times 6, I could probably do this in my head, and you could too, because we know that 3 times 6 is 18. So we have 18 whole. And then I'm going to have 6 halves also, because we did this, right? 18 of these, 18 whole. 6 halves is equivalent to 3 whole. So I have 18 plus 3. And that's going to give us, what, 21? And just to make sure that, you know, to prove this to you guys, I'll do it the other way too. 6 times 5 is 30. 6 times 3 is 18, plus that is 21. And we have one space here, so we have that. So in your head, thinking 3 times 6 and 18, and then you could do 6 halves, and that's 3, and that's 21. So we have now 21. And we now know that 35%, so part of 60, that is 35%, is equal to 21 out of 60, right? 35% of 60 is 21. Let's try another. 5% of 180. So 5% is part. The whole of any percent is 100. And 180 is the total, because we're trying to find a part of 180. We're trying to find 5% of 180. So now we have to ask ourselves, how do we go from 100 to 180? Well, actually, in this case, if you think about it, it is just a simple multiplication, because if we multiplied 100 by 1, that'd be 100. But we don't want 100, we want 180. And if we multiply 100 by 1.8, remember, anytime we multiply a number by 10, it moves one place to the left. But in this case, we have 10 tens. So both digits move 2 places to the left. So this times 100 will give us 180. And again, if you just think about it, that's one group of 100 and then 80 parts. I'm sorry, 8 tenths of 100. 8 tens are 80. So this one was kind of easy. And so we go from 5 times 1.8, and that'll give us the part we're looking for. And again, we could do this in our head. 5 times 1 is 5. I write that off to the side, 5. And then 5 times 8 parts would be 40, right? 5 times 8 is 40. But in this case, since it would be here, it would be 4.0. So we have now 4 more ones. So we have 5 plus 4 because we had those 5 ones from before. And that's 9. So in this case, 5% of 180 is 9. Also, if let's say you didn't know how to go from 100 to 180, you didn't realize you could multiply by 1.8. We could do the thing we did before. We could move this down to 10 and then multiply 10 by 18, right? Because 10 times 18. So let's do that. What would this look like if we move this down to 10? Well, this to 10 means we divide by 10. And so we would do the same with this guy. We divide by 10. 5 divided by 10 is going to be, again, every time we multiply by something by 10, or divide something by 10, excuse me, you move that digit one place to the right. So 5 divided by 10 is 0.5 or 0.5. Okay, how does this help us? Well, now we can move from this to 180. And I'm going to write this over here so you can see this better. So 10 going to 180, multiply by 18, multiply 0.5 by 18, and you'll find out that, again, 0.5 is half. So what's half of 18? 9. Okay? Either way works. But just know that you want to set this up in a way that says whole is equivalent to the whole, which the part should be equivalent to the part. So you need to identify with, is this the whole or the part? Is this the whole or the part? You'll see as we move on. I'm going to skip these next ones because things are going to get a little bit more tricky now. Here we go. The school principal spent $2,000 to buy some new computer equipment, and of this money, $120 was used to buy some new keyboards. What percent of the money was spent on keyboards? I've talked about this before. When you read through a word problem, that's a lot of information. Nobody expects you to remember everything you just read the first read. So I hope that you always, after reading through one time, just to get an idea of what's going on, that you go back and you break it up piece by piece. And we're going to do that right now. The school principal spent $2,000 to buy new computers. He spent this total amount. This is the whole amount, okay? Again, it's important for us to identify what's the whole. The whole here is $2,000, okay? I'm going to put the whole on the bottom. For computers. Of this money, of this whole, part of it, 120 of it, was used to buy keyboards. Part of it, how much was that part? 120, okay? So far we have a whole amount, we have a part. What percent of the money, so what part of the money, of this money, no. What percent of the money was spent on keyboards? So what part of this whole was spent on keyboards? What would be, if we're dealing with percent over here, what would be the whole? The whole always for percent is, even if they don't tell us, is always 100, because 100% is always the whole. That means we're trying to solve this. What percent of the money, what part of the whole was, in percentage, was spent? We know it was $120, but we want to know what percentage this is of this. Okay, now that we have our proportion set up, this should look okay and something easy to do. How do we go from 100 to 2,000 or vice versa? Well, we know, I know if I multiply 100 by 10, that will give me 1,000. But I don't want 1,000, I want 2,000. So I'm going to multiply it by not just 1 10, but 2 10s, 20. So if I multiply by 20, that helps. And if I multiply by 20, that helps. But wait a minute, we can't do that because we don't know what to multiply 20 by to get this. So let's back up here. We can't multiply by 20 in this case. We can, but we don't know what this guy is. So instead we're going to do the opposite. we're going to move this way. And we'll say, hey, 2,000 divided by 20 is that. So the same could be for over here. I mean, it has to be. Divide 120 by 20, and you will get whatever that part is. So 120 divided by 20 would be, let's see, there's 120 right there, 1, and then there would leave us with 100, which would be 5 20s. So that's 6 20s. So 6. And let me check. 6 times 2 is 12 times 10. Yeah, 120. $120 spent out of a whole of 2,000 is equivalent to 6 parts out of 100, or 6%. In fact, we haven't yet answered the question, have we? What percent of the money was spent on keyboards? This is the whole percent. We want the part. 6% of the money was spent on keyboards. I'd like you guys to write out your things in sentences when you do this. It's just a good practice. I know I don't do it all the time on this, and I need to be showing you guys that. So I'm going to try and keep that up. Make sure I do that as well. All right, check this out. Out of the 25 students in Mrs. Green's class, 19 have a pet. Okay, it's about animals and a class and students. Out of 25 students in Mrs. Green's class, okay, Miss Green has 25 students, 19 of those students have a pet. What percentage of the students in Mrs. Green's class have a pet? All right, let's identify what we know. Can we identify any wholes? Out of the 25 students in Mrs. Green's class, 19 have a pet. Oh, Mrs. Green's class has a whole of, okay, this is a whole. And so I'm going to write 25 on the bottom. And by the way, we know the whole of the percent because it's always 100. So there's our whole. 19 of those 25 have a pet. That's the part. 19 have a pet. 19 is the part. What percent? Well, look, they don't even need to ask the question because we realize, well, they do need to ask the question because we need to recognize what they're doing. What percent of the students have a pet in Mrs. Green's class? That's what we're trying to figure out right here. And so, again, we can't move around up here because we don't know this figure, but we can figure out the relationship here. So can we go from 25 to 100 or 125? Sure, we can. Let's see. If we move this way, that won't help because we can't move this direction because we don't know that. So we want to move this way because we can move this way up there. So 25 to 100, oh, that's like quarters, right? You need 4 of them. 4 25s make 100, and so we need 4 19s. We could do this in our head. 4 10s would be 40, and then 4 9s would be 36. So 40 and 36 is going to give us 76. And lest I don't do what I just said before, answer the question, Mr. Reichert. What percent of the students in Mrs. Green's class have a pet? 76% of the students in Mrs. Green's class have a pet. Okay? All right. Let's skip ahead a little bit here. Okay, let's try this one. 12 of the students in the school choir like to sing solos. Okay, we're dealing with students in a school choir singing solos. 12 students in a school choir like to sing solos. These 12 students make up 24% of the choir. So these 12 kids aren't the whole class. They're just part of the class. In fact, they're 24% of the class, or the choir, I should say. How many students are in the choir? Oh, this is our whole. They're asking for how many total students are there in the choir. We know that there are 12, at least 12, because those 12 like to sing solos. Okay, so let's write this down. Let's write down our wholes and our parts. The first number I see is 12 of the students. Okay, so 12 students. Is that whole or part? Hopefully you guys realized, based on the question, that this is only part of that class. So we can write 12 as our part. And let me finish writing this. Our proportion, 24%. Oh, that's part, because we know that the whole is 100. So I can write that. This is also the part. And we know that the whole for a percent is always 100. I think we have everything we need. We can figure out this relationship, and that'll help us figure out what this missing piece is. So should we go this way? Yeah, we should, because we can deal with this and we could deal with this. So let's move this direction. So 24 to 12. 24 to 12. How do we move from here to here? I hope you realize that if you divide 24 by 2, you'll get 12. That means if we divide 100 by 2, we'll get this missing part, which is, whoops, let me use same color, which is, no, sorry, which is 50. Okay, 100 divided by 2 is 50. And now we can answer this question. How many students are in the choir? Well, this is the percentage of students that like to sing solos. This is the whole class. Here's the number of kids that like to sing solos. So this is the whole class. So we can say, did I just say say? Let's see. How many students are in the choir? There are 50 total students in the choir. Good. Again, we can use proportions. All you have to do is identify all the where are the wholes and where are the parts, stack them up, make sure that the parts are with the parts and the whole with the whole, and you can figure it out. Let me skip ahead. A store has 300 televisions on order, right? To me, it's already sounding like this is probably the whole, but we'll keep reading. A store has 300 televisions on order. 80% are high definition. Okay, out of this whole number of televisions, out of the 300, part of them are high definition. So we have a part, right? How many televisions are high definition? Aha, we want to know part of this. How many of these 300 are high definition? And so we can now set up our ratio. The 300 is that whole, and we know that the other one's going to be a percent, and the whole is going to be 100. And we also know that part of the total amount, part of the percent of the TVs that are high definition are 80. So we now have a proportion set up that we can work with. Should we move this way? Yes, we can deal with this and this, so we're going to move in this direction. How do we go from 100 to 300? We multiply it by 3. How do we go from 80 to that? We're going to do the same thing as we've done at the bottom, because when we multiply something, the same number over the same number, it's multiplying by 1. And so 80 times 3 is, 8 times 3 is 24. And so 24 with a 10 is 240. So how many televisions on order are high definition? Well, 80% of them, of this total 100%, which is equivalent to 240 of the 300, are high definition. So there are 240 HD TVs. I'm just going to shorten it for time's sake. All right. Let me skip ahead to one last problem. And I hope this is making sense as we keep doing these same types of things over and over, because really this is, we're just doing the same thing. We're given parts and wholes, and we set them up in a proportion, and you can solve for the missing part or the missing whole or whatever it's asking. Let's look at this. At Pizza Pie, 9% of the pizzas made last week. 9%, that's part. I'm just gonna stop and say, hey, that's part, and I'm gonna identify that as part. And since it's a percentage, I already know the whole is 100, unless I read on and there's something different. At Pizza Pie, 9% of 100% of the pizzas are made last week had broccoli on them. So these, good thing I used green, okay? These are our broccoli pizzas. By the way, I would never eat that. If 27 pizzas had broccoli, so this 9% is equivalent to 27 actual pizzas. Oh, so I can stop right there and identify, hey, that's another part. That's this part, right? These are the actual pizzas over here. This is the percentage over here. So 27 pizzas had broccoli. There's the 27. That's 9%. How many pizzas in all? Oh, well, duh. We didn't even need to be asked that question, essentially. I mean, because we can see that this is the missing part, so this is what we need to find. Part, whole, whole. So which direction should we move? Well, find the fraction that has numbers on both numerator and denominator for us to deal with, and we'll move from them to the other side. So let's move this away. 9 to 27, well, that's multiplied by 3. And so 10 to over here is going to be multiplied by 3, and that's, sorry, that's going to be 300. So how many pizzas in all were made last week? Well, 9% of them, which is 27 pizzas, had broccoli. So there were 100%, and 100%, that means all the pizzas would be 300. So 27 of these 300 pizzas had broccoli. The rest I would actually eat. Okay? And let's see, how would we write this out? We would write it like this. We would say how many pizzas in all were made last week? There were 300 pizzas in all made last week. Woo! There we go, guys. I hope this was helpful. Proportional reasoning is an awesome way to solve for a part that you don't know. If you're given parts and wholes, set them up as ratios, set them up in equivalency, and then look at them, and you can use your mathematic detective skills to figure out what that missing part is. What I want you to do this for this assignment for lesson 8.3 is to complete any 10 problems you want to from pages 223 and 224. And I'm gonna ask you to challenge yourself. Don't pick the easiest 10 problems. Come on, you can do this. Go for some of those word problems. In fact, most of what we just did today were word problems, and look how simple it was. So go ahead and attack some of those. If you have any questions or concerns about any of what we did today, if I made any mistakes, point them out, please, so I can correct that. And that's all I got for you guys for this lesson. See you next time.